All right. Let me zoom in here. And all right, is this font big enough for people?
Make it a little bigger.
Yes. You see that?
Perfect, thank you.
All right. So yeah, so what I'd like to do now is we're going to use object-oriented programming style, and we're going to model a Netflix system. So this Netflix system is going to have a couple things. So we can talk about entities, the kind of entities we want. So we'd like to have users, and we'd like them to be able to rent movies. And then they can watch those movies, and then those movies will be removed from their saved movie list or something. So we talk about the entities. We know we're going to have some kind of user class to represent users, and we're going to have a movie class to represent movies. And then what we'd like is for a user should be able to save a movie to like a saved movie list, and then once they've saved the movie, then they can watch it whenever they want to later. So we're going to need some kind of structure to store movies in. So I'll just call it so we can talk about how we want to implement that later, but we're going to need something like that. And then so we've been dealing with CSVs as a form of persistence to kind of represent databases, and CSVs are actually really used in real life, but we use them here to kind of represent databases. But so what I'd like to do today is, instead of reading from a file, we'll make an API call. So we'll go out into the internet and we'll get our data that way, rather than reading from a file we have locally. So we'll have we'll call it the movies API. So we'll make a request to get some movie, and then we'll kind of mock it that way. Okay. So I think that should be okay for our entities. And then if we let's talk about maybe some behaviors here. So we want users to be able to, let's say, save movies. We'd like users to be able to watch movies. Something like that. I think that's good for now. And then for the movie, I think movie could probably be pretty dumb. I don't think movie has to really. I don't think it has to have any like actions. I think it could just have data. Like maybe, I don't know how you want to represent that. I'll use a plus sign for data, somewhat arbitrary, and we'll say it has a title and an ID. We'll keep it simple, and then the saved movies. So this is going to represent the storage, so a user's storage. So if we think about the data structure we want to use, there are several options. We've gone over stacks, right? So what's a stack?
Like first in, last out. You just keep piling up on top of the first.
Exactly. Yep. So what do people think about that? Is a stack a good data? What are the pros and cons of that?
I mean, con is you couldn't just select a certain movie out of your save files. You'd have to go from the last one in down.
Yeah. Yeah. So depending on what you're doing, I'd say for this case, we could implement it that way, but that would reflect a kind of a business decision, right? So if you have, a queue, for example, like the original Netflix where they actually mailed out DVDs, that's kind of how it worked. You would select all the movies that you want and you would have them like in a queue, and then the first one off, like whenever that first one became available, they would just take it off and send it to you. So, but I think for like an on-demand system, that doesn't make sense. So we'd like movies to be saved, but we don't really care about the order that they're saved in. And we want a user's movies to be searchable, right? So we'd like them to be able to, okay, I want to watch this movie, and they can search for that and then watch that. So if we want, we don't care about the order, and we'd like searchability. We have a few options. I think the simplest would be just to use a list. So that would be like the underlying structure, and then on top of that, we could also use a dictionary potentially, but we'll just use a list, and then we'll add an interface which is useful for our purpose. So we'll say that there'll be some kind of storage, which will make a list, and we'll have some methods. We can add a movie, and we can, let's say, remove a movie. Okay, so we might take a step back here and think about, okay, so we have this saved movies, this this entity which basically stores and then can add and remove movies from its own internal storage, and the user also presumably is going to be either indirectly or directly manipulating this, right? So if a user watches a saved movie, then that movie is going to get removed from the saved movie. So we're seeing like that there's probably going to be some kind of relationship between here and maybe save movies and add movies. I'm not sure how that is, how that works right now, but it's something to think about. Okay, and then the movies API. So this is going to act as basically the source of information we have about a given movie. So again, to keep this simple, I'm going to say that we just fetch a movie from this. So we'll call fetch movie or fetch movie info, something like that. So let's see. Is someone trying to get in here? Sec. Okay, that's fine. All right. So yeah, so we have our entity. So our user can save a movie into some kind of save movies storage system, and then watch a movie, which will remove that. And then when they actually want to get, so we can do that, but we're kind of like relying on the user to know all the information about a given movie. So we don't want to do that. We have, we're going to pretend we have basically, like a database of actual movies. So it's not like the user can just make up a movie to watch. You have to choose from what's available. So to take care of that issue, we're going to have the movies API. So we're going to control the movies that are available for a user. Okay, so I think that's probably good for right now. So we can start implementing some of this stuff, or at least stubbing it out. So I'm gonna go, let's see, I think I'll split this down. And so we can just start creating files and then adding the classes there, which is fine. But I think a basic structure for any project at this point, we're gonna have like a core module with actual code, and then we're also gonna have to write tests. So we're gonna need some kind of like the source code module, and then a testing module, and then we're probably gonna have some kind of entry point, so a runner or a main, some kind of main method, so some kind of entry point. So those three things you can roughly guarantee are gonna exist. So we can go ahead and create that structure now. So I'm gonna call the kind of source code src. You don't have to call it that. That's often a name you get. And then inside of the source folder is where we'll put all of our entities like user, movie, and we could have further subfolders in there, and often in complex projects you do, but I think that's good for now. And then we'll also have a tests folder, and then at the top level we'll have at the top level we'll have an entry point, which we can call runner or main or whatever we want. I'll call it runner because that's kind of what we've been doing. Okay, so the basic project structure is set up now. So now I'm going to go in, into source, and I'm going to start creating these entities. So I'm going to have a user. Actually, I'm just going to do this on the command line. So cd. So I'm going to need user movie. I'm going to have saved movies. And when I'm doing Zoom, I often get weird delays here. One sec. Yeah, that is not what I want to do. Okay, and then save movies, and then movies API. Okay, so I've got that going. So let's go ahead and let's start writing the classes. So I'll start with user, class user, and a user. So we didn't talk about the specific properties that a user might have, but I think at minimum, let's say you have to have a username. So we're going to create a user. So def. I'm going to keep this as simple as possible. We could make it much more complicated. So self and then username. And then we've got our two methods, at least so far. So def save movies. I think maybe just save movie, right, one at a time. And for now, we don't know what that's going to look like. Okay, and then let's go to the movie. And then I don't think we need, so we have a title and an ID, so we'll just, I think this class will be pretty simple. So okay. And then let's go on to save movies. So save movies is a little more complicated. So we're going to need some kind of storage. So we can put that in the init. So we don't need to pass that in. We just know that we're going to have some kind of underlying storage, which we've decided to be a list. It could be something else. Okay. And then we're going to have a couple methods. So def add movie. And probably going to need to take in a movie. So we can just maybe stub that out. We don't need to, well, yeah, maybe we shouldn't start writing this yet. Def, and then we're going to remove a movie. And we're going to need something. Let's just leave this for now. We'll figure out how we're going to search for a movie and remove it. And then the movies API. And I'm not sure that we will need any properties. So I'm just going to have def fetch. We can always add this later if we need to. And then, okay, so I think we have everything stubbed out. I do know that, as I said, I'd like to make a network request and get back, a response from the internet somewhere. So in order to do that, I'm going to use, for the sake of convenience, I'm going to use a third-party library. So in order to do that, so now I know my project is going to have a third-party dependency. So I'm going to need to install something. And in Python, the way that we do that, I could just install it globally on my system, but that's almost always a bad idea for a few reasons. One of them is that you're probably going to have multiple projects going on your system. And so if you have lots of different versions of the same thing, it can create conflicts. So things can get complicated very quickly. So we want to isolate whatever we're doing to this specific project. And in JavaScript, you would use the package.json to control that. In Python, Python uses a slightly different system, but same idea, called a virtual environment. So I'm going to go back to my root here, and I'm going to create a virtual environment. So a virtual environment is basically just going to kind of mock you don't really need to know how it works, but it's basically going to like mock the rest of your system. So it's going to pretend that this project is your whole system. And then so we're going to do that, we're going to go Python -m. Does anyone know what the -m is for? So the -m flag allows you to run a Python module on the command line. So we've seen, like, when we import modules, like, regular expressions. So you can, RE is a module for regular expressions. You can have functools so these are all standard library modules that we can import. You can, depending on what the module is and how it's set up, sometimes you can run them actually just on the command line. So instead of, like, I have a file, I'm going to import it, and I'm going to write some code, and I'm going to run the file, you can just kind of run the module directly. That doesn't always make sense as a thing to do, but sometimes it does. So in this case, virtual environment, we can do Python -m venv. So we're going to run this venv module, which we could do that, but it just doesn't really make sense. And then we're going to pass it an argument. And the argument is going to be the name of our virtual environment. So this name doesn't really matter. Often I'll just call it this is actually just going to create a folder in our at our root level here. So I'll press enter. It's going to take a second. I'll just click yes here. But so now we have this new folder called virtual environment, and you don't need to worry about what's going on here, but this is basically now set up to treat this this as like a subsystem, so isolated from the rest of your system. And now once we do that, we have to activate the virtual environment. So we've created the virtual environment. Now we need to basically enter that virtual environment. So that's source, and then the name of the virtual environment, virtual env, and then we're actually going to run a script. So when we created the virtual environment here, it included a whole bunch of stuff for us. One of those things is a script that will allow you to enter or activate that virtual environment. So here's the path of virtual env and then bin and activate. So you don't need to worry about that, how this works, but that's what it's doing. Okay, I'm gonna execute that. And now, just because of the way that my bash profile is set up, I can see that here. So I can see that I'm in the virtual environment. So that's good. So now I know that I'm working inside a virtual environment. So now I can install whatever I want to install. And it's not going to pollute the rest of my computer. So pip install requests. So there's a library, third-party library called requests, which is kind of the go-to for doing this kind of thing. And once I have that, it's installed. And if I do pip list, for example, I can see everything that I have installed in my local environment. So this is not my computer as a whole. This is just my virtual environment because it's isolated now. And I have all this stuff. So I installed requests, setup tools, and pip basically are always going to be there. But requests also has some dependencies. So request went ahead and installed its own necessary dependencies. Now, at this point, if I were to save this, push up the code, and say, okay, we'll go ahead and run it, there would be a problem because I haven't told people what they need, right? It would be like pushing up a node project without the package.json. It's like, okay, I have all this code, but I don't know what other modules I need in order to make it work. So one way of doing that is to create something called a Requirements.Txt file. And basically the Requirements.Txt file is just going to be this stuff right here. So we're going to say, hey, if you want to run this, you need blah, 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 blah. So a quick way to create that is to go pip freeze. Pip freeze basically does the same thing as pip list, just it will show you everything you have in your current environment. And then I'm going to redirect that to a text file. So I'm going to pip freeze and then redirect it to requirements.txt. And then this requirements.txt file gets created, and I can see here that basically if I want to push this up, everyone knows, okay, here are the requirements, here are the modules that I need. So if I push it up and someone else wants to run it, then they would do pip install, and then they could pass in all this stuff here. Okay, so you don't need to worry too much about that, but just as a introduction. Okay, so I know I'm going to need this third-party library called requests, so import requests, and now I can import that and everything's fine. So I'm not using it, but I've set up my virtual environment correctly, and so this is now available to me. Here's some, we can look at the documentation. If you want to do that later, we can, but the usage is pretty simple. So anyway, okay, so we have that available now, and let's go back and look at our specs one more time just to get the big picture again. So we're making this making this Netflix system, and we've got a few entities. We have user, movie, save movies, movie storage, and the movies API. So a user should be able to save movies into the save movies queue. And in order to get information about a movie to save, a potential movie to save, we're probably gonna have to hit the movies API. So the user is gonna basically grab a movie from the movies API and then save it into the list, right? And that somehow we're gonna have to create an instance of a movie when we do that. So we're gonna fetch a movie from the API, create an instance of a movie, and then we'll add that movie to this saved movies list. And once that list is populated, then the user can watch a saved movie, which we'll check inside of saved movies and see if it's there. And if it is, we'll remove it and say, the user watched the movie. So that's the basic interaction, I think. So let's go here. Let's see. So a user is going to need to save a movie, which means that the user is going to have to make a call. So first thing, let's say, in this case, we're going to keep it simple. So we're just going to say, you're just going to get a random movie every time. So user is going to get a random movie. And then we're going to, let's say, save that movie to the save movies list. So if I know that the user is going to have to get a random movie, and we also know that we get a random movie from the movies API, then the user is going to have to either directly or indirectly interact with this API. So there's a few ways we could do that. You can set up multiple levels of indirection, but for now, I'm going to say that user is going to need access to the movies API. So I'm going to give the user an instance of the movies API that the user can use. So self dot okay, so right now my linter is mad at me. Movies API is not defined. So I'm going to have to import that. And another thing that you'll probably want to do, it's not strictly necessary, but it will be when we run the tests later, is that you can mark this as a module. So we have a bunch of files, and that's fine, and we can import them and do all that stuff. But sometimes it's nice to formally define this as a module, and the way you do that is you create this dunder init.py file, and it can just be empty. You can also do stuff there, but we don't need to worry about that. So I'm going to create that there. I'll also just create one in the tests, because we'll have to do that later anyway. So dunder init.py. Okay. So here now I've created a module, so that will make our life easier in a little bit. Okay, so this user, it needs a movies API, so we're gonna have to import it. So from source dot movies API. Okay. So I'm just giving basically the full path here. So source.movies API, that's where we are. We're going to import movies API. So now we can use this. We're also going to need, so we're going to have to do something here. So get a random movie here. And we're also going to have to save that movie to the save movies list. So again, we've got this one entity interacting with another entity. So how do you want to set up that? There's a few different ways to do it, but I think just giving user an instance of the saved movies list, that makes sense. Self dot saved movies. I think that's called save movies. We'll see. And then I'm going to import that. So from source dot save movies. Save movies. And then when we create an instance of save movies, I don't think we have to do anything. Yeah. Okay. So I think that's probably good. So, we started with an initial design, and we knew that somehow there would have to be an interaction between users and movies API maybe and save movies. Now we've decided that this is how we want to set it up. Okay. So once we do that, we're going to need to get a random movie. So let's say we'll call self.movies API, and we have a method on movies API to get a movie, which is called fetch movie. So this doesn't do anything because we haven't written it yet, but we know that at least initially this is probably what it's going to look like. Maybe we can adjust that later. So we now know that we're going to have to use this. So let's go ahead and maybe implement that in the movies. So we got, where are we? Movies API. Okay. So I have a couple of things. So in the real world, and as you're doing projects, people don't want to just give away their information for free. And so to use most APIs, you're going to have to create an account, and then you get a key, and then you include that key with your request, and blah, blah, blah. So it's a little more complicated, but there are a few free APIs. So I'm going to use that just to keep things simple. Let's see. So I couldn't find in the half hour or so I looked like a free non-token requiring movie API. So we're going to use two, and then we're going to just kind of fake it. So here's one URL. So if we go here, we can actually let's see if I can do this. Actually, I'll just run it on the command line. So I can curl. So curl, and pass that in, and I get what kind of thing is this? This blob here?
Ingredients for beer.
Yeah, but so yes, it's ingredients for beer, but what is the type of thing that this is?
Oh, it's a dictionary.
JSON.
Yeah, it looks like a dictionary, and it's meant to be like isomorphic with the JavaScript dictionary. This is JSON, yeah, JSON object notation. So this is the most common format for sending and receiving information over a network. So making requests like this. So I can make that request, and I know that I get JSON, and I can look at the structure of the JSON. So for example, let's call this beers URL. And then there's another one which I have, which again I apologize for. So sorry, my mouse is on the very edge here. Okay, so and then here's another one. So same thing, we're getting JSON. It's got a slightly different structure, but there you go. So we'll add this. Okay. And so I think what we'll do is what I decided to do is just take like the name and then I'll combine it with like this thing. So we have the URLs here. So how do we actually use requests to get that information? So we're gonna use let's do beer's response is requests dot get. So we're gonna make a get request. Oops. We're gonna make a get request and we pass it in a URL. So, and then this is going to return a response, which is, a class in requests. So it makes this request and it will return another object to us, an instance of some class in the request library. And that class has a couple methods on it. One of them is basically encoding to JSON. So we can take some JSON object and then convert it into a dictionary in Python basically. So here's response dot JSON. So that should give us this, or in this case, this thing. And then from there, we should be able to access keys. So we can do just like a dictionary, we can access it. So let's say we want the name. Let's do your name. So it should be equal to that. And just so we can test this out, do something initially, I'll do beer name. Okay, so I'd like to do some kind of ad hoc test here. So a couple ways I could do that. I could isolate this. So eventually, like ultimately, this is going to be used as a module, right? It's going to be imported somewhere, and then the rest of the code is going to do that. So no one's going to run this directly. If we want to do some, ad hoc testing that will be controlled, that won't run when we actually use it for real, we can include an if name equals main statement and run our kind of local tests there. So if name equals and we will call, let's see, we'll create an instance. So and then m.fetch movie. Okay, so now I can run this directly here. Where am I? So I'm going to go into source. And I can do Python. Okay, so I have this right here. I ran the file directly, so this condition is met, and so I got my little ad hoc test. So I can see that this is working so far. If we switch over to the runner now, and I'm going to import just for the sake of showing this. So from source dot movies API. I'm going to go ahead and create an instance equals movies API. And let's see. Yeah, so I think I'll just create the instance. All I would really have to do is import it to show this. But so when I import this line is not going to run, even though I'm importing it. So it's it's reading this file in. It's not going to actually run what's under here. So if I go back out to my root level and run Python runner.py, you can see that this did not run. So that's one use case. I wouldn't, this is something that you can do like as you're developing for kind of easy testing, so you're not messing everything up. But I wouldn't include a whole bunch of junk like this. But anyway, that's kind of how this thing is originally meant to be used. Okay, so we've got our fetch movies. So we know how to get a movie now. We're gonna make the request.get, and then we're gonna convert it into a Python dictionary. We can pull out the field that we want, in this case, name. So I'm gonna do the same thing. So we're gonna also get appliances. So appliances URL, and then so I want to get the equipment. So equals, and then we'll do the same thing. We'll take this response, the instance of the response object, and there's a JSON method which will convert it for us. So appliances response.json, and then we're going to grab the field that we care about, which in this case is equipment. Okay, and I'm not doing like error checking just for the sake of time. So we could do this, and if I'm gonna go, I'm gonna run this file directly, so I get the little my ad hoc test going, and this will be use PI. So I think this worked, IPA, and then I don't know what this is, but we'll go with that. And then I'm gonna let's see. Anyway, so we'll pretend that the combination of these two names is our movie name. Oh yeah, we also need to get the ID because our movie needs an ID. So I think there was an ID field on here. Yes, there's an ID field. So we'll grab that too. And then I'm gonna return. Well, so there's a question about what we should return. So we now have like the information that we need for a given movie, but what we actually need is an instance of a movie, right? So we're taking this kind of raw data and we need to format it, right? We need to make sure that it conforms to this model that we have, movie, so it can be used by the rest of our application. So user, we're gonna get a movie, and it's expecting a movie, like an actual movie object that can be saved. So we could do this in a couple places, but I'm just gonna go ahead and say that this movie will return like a movie in our system. So we're gonna return an instance of movie. So I'm gonna have to import from source.movie. And then I'm going to create an instance of this movie to return. And this movie takes a title and an ID. So the title, let's say, is quotes. We'll just combine the first, appliances response, and then space, and then equipment name. And then the ID, which will just be the ID. So why is this highlighted blue here?
It's a protected name.
Yeah, basically. So Python, what IDE is telling me or warning me about is that ID is a built-in. So it's like a protected name or what's the term for that? A keyword, yeah. I forget the official term, but you know, it's a word that Python uses. It reserved word. So a couple things you could do, you could, you know, maybe add something like that, or just change it, like, you know, movie ID. See, this is not directly a problem, but it is a problem. So for example, if I do ID of, I believe ID will give you the, well, let's see what it does. I think it gives you the memory address or something. So X, I'll print this. Okay, I'm just gonna do this on the, I'm gonna go in here and I just want to do a quick experiment. So I'm gonna open up the REPL and I'll do X equals hi. And then I'm gonna call ID on X. And we get a number. So I think this is the memory address. But anyway, it's a built-in function that Python has. So what happens is if I say ID equals blah blah blah, and then I try, oh well, I would really like to know what the memory address is, so I'm gonna call, you know, ID of the beer name. What's gonna happen here? Let me see. Okay, so yeah, so we're having an issue where because we're running it from right here, the file path is getting, so let me run this from the runner. Not such memory. So it's I know that ID is a built-in, and I just ran an example in the REPL, but now it's telling me when I try to run it here, when I try calling it, saying the int object is not callable. So what does this error mean? What does it mean that something is not callable? But it basically means that it's, oh, go ahead, yeah.
I was gonna say, I mean, it's not a function. You can't like call it and pass arguments into it, right?
Yeah, essentially, yes. So I can't call it. So the reason I can't call it, even though it's a built-in, is because I'm overwriting the built-in here. I'm taking a name that Python has given to this function, and I've said, you know what? No, you're actually, I'm gonna like reassign. I'm gonna reassign a value here. So instead of being this method, ID is now going to be this thing, which is an integer. So I can't call an integer, right? In Python, I can't just call it an integer as though it were a function. So in testing, this is called monkey patching. So we'll see. This is kind of like how mocking works, actually. You're taking a normal built-in, often a built-in function or function that does something else, often a side effect, and you're saying, you know, during the course of this test, I'm gonna override the value so it doesn't actually get called, so I can control it, and I'll give you something that you can use just for this test. So one you want to make sure that you're not stepping on Python's toes. In this case, it wouldn't matter, but it's just a good practice to avoid doing it because you can get weird bugs. And two, in testing, that this is kind of like how mocking works, basically. Which is one reason why mocking is bad and a reason why you should use pure functions. But we'll talk about that in a second. So I'm going to change this to movie ID, and I'll add that here. Okay, so now this fetch movie returns an instance. So I'm gonna do another quick overview of our system so far, and then we'll take a 10-minute break. Okay. So we have our user, and the user should be able to save a movie, which is going to have to, in order to save a movie, you have to get a movie. So we're going to get a movie from the API, and then this fetch movie, which we've just implemented, now returns an instance of movie. And once we have an instance of a movie, then we should be able to save it. We'll finish implementing that. And then user should also be able to watch a movie. And in order to watch a movie, that's going to require accessing this saved movies thing and searching for the given movie. And once that's found, it will be removed. And then we'll, say that the user watched the movie. So that's the basic idea so far. So we'll finish implementing this and then we'll write some unit tests. So take 10 minutes and yeah, take 10 minutes now. All right. So we'll come back here. And so we've got our Netflix system. We've got movie, the movies API, save movies, and user. So we've just implemented this movies API fetch movie method. So we're making API calls, we're getting some JSON back, and then we're pulling out what we need and just combining it. So we're creating this kind of dummy movie object, which could represent reading from a database or from some local file system, or in this case, an API call. Basically could be really anything, but in this case, it's an API call. So we get an actual instance of a movie returned from here. So user is the one who's going to be responsible for calling this method, and this should return an actual movie. Okay, and then once we have a movie, we're going to need to save it. So we have this movie now. This is an instance of a movie, and we're going to have to save it. So we're going to have to go into saved movies, and we're going to have to start implementing this stuff. So looks like add movie, it was a pretty simple implementation, so just add it. So I think that's already taken care of. So we could probably go back to the user and just call add movie. So self that saved movies, add movie. So I think that should basically do it for that particular method. So let's go to our runner and we'll see how this works. So I'm not going to call movies API. I'm actually going to create a user. So I'm going to import. And I don't need to call that directly anymore. And it's going to take a username. And then I'm going to call save movie. Yeah, save movie. And when I call save movie, that should make a request to the API. So, a user should be included, should come included. An instance of movies API should be included with the user, as well as the save movies thing. So we'll save the movie, and then when we do that, we should be able to check if our saved movies .storage is populated. So we'll just do a quick sanity check there. So saved movies dot storage. I'll just print this out. Okay, so it looks like that worked, but this is not a very pretty representation of a movie. So is there any way that we could fix this or customize it to get something a little more useful?
Oh, we could do a string method,
Okay.
but in the fetch movies method, I think for our movie title, you're calling like the whole appliance object or yeah, instead of having beer name and equipment name, we're gonna have like all of appliances response.
Thank you very much. Yeah, this should be beer name, let's say. Thank you. Beer name and equipment name. Okay. Yes. Cool, thank you. So in movie, yes, so we can override the string method, so def str. And we could return whatever we want here. I'm gonna return. I'm gonna do movie. I'll make it look like the thing. So self dot title, comma. All right, so I save this and I'm gonna call this again. And this, I still get this movie object, but now what I can do is I can, if I access this directly, this should be, yeah. So I can see that it's a movie instance, Samuel Smith's Imperial IPA oil heater, and then the ID. So interesting movie. Okay, so now our user can save a movie, which is gonna fetch this movie from the API. So we're gonna go off onto the internet, get something back, create an instance of a movie with it, and then save that to this storage. So in doing this is fine. Maybe just for convenience, we could add like a show, some kind of show method here for the save movies. So I'm gonna add a def show movies. And I'm just gonna do for movie in self.storage. Print movie. So now I should be able to, from the runner, instead of doing all this stuff, I could do show movies. I call this again. And I get a none. Yes, so I shouldn't be. I can print the return value, which is going to be none. So I call it one more time, and then I get what I expect. Okay, so if we go back here, so now we need to, well, that's actually good enough for now. If we're focused on like, what does the user need to do right now? So the user can save a movie. Now, if we go back here, the user needs to be able to watch a saved movie. So watching a saved movie. So what we are going to need to do is we're going to have some kind of identifier, or it could be anything. Maybe we search for it. To keep it simple, we'll use the ID, the movie ID. So we'll pass in the movie ID. We're not going to worry about how the users would get that. We could have another method that gets the ID based on a search query or something like that, but we'll just cut to the chase. So we'll have an ID, and then we're gonna have to search through the saved movies to find that ID, and then we'll remove it from the list, and so on. So in order to watch a saved movie, we'll have to search. So we're gonna have to pass in an ID, I think. So we'll pass in a movie ID, and I'm gonna call self.saved movies, and then remove movie, and I'll pass it the movie ID. So we haven't implemented this yet, but we know that we're going to want to basically search for and then remove and return that movie. So this should be a movie, assuming that we actually have this saved. So we might do some kind of check. So let's say that if the movie doesn't exist, we'll return none or something like that. We return some bottom value, and then we'll do a check. So if movie to watch, so if this is an actual movie, then we'll print you are watching, and we'll do movie to watch dot title, and then otherwise, so if this movie wasn't found, we'll say you haven't something like that. Okay, so now that we have this method kind of does what we need it to do at this level of abstraction, right? So we somehow need to get an ID, we know that. And now we're gonna have to dive down here and actually implement this. So this remove movie. So remove movie now. So we know we're gonna pass it a movie ID. And we're gonna have to, I'll just write this out. So we're gonna have to search in storage for the movie ID. And we're gonna have to remove. We'll have to check if it's found. Remove it and return. And if it's not found, we'll return none, because we decided, or some, false value. We decided here that that's what we want. We could do something else, but that's what we'll do for now. Okay, so we got to search. First part is searching in self.storage for movie ID. So what is self.storage going to contain?
Movie objects.
Yes, exactly. So let's iterate through that. So for movie in self.storage. So we can check, since these are all movie objects, movie objects have IDs, right? Because we told them to have IDs. So this will actually be fine, even though this is highlighted. Okay, so we're gonna do, so if movie.id is the same thing as the movie ID that we're passing in, then we know we found one. So we're gonna have to, I'll do this over here. So if we find it, we're gonna have to remove it. So how are we going to remove it?
Self.storage remove movie.
Yeah, we could potentially do that. Think remove first occurrence of a value. So yeah, I looks like we could do that. So this will throw an error if it's not there, which is, I think is okay. We could handle that. Does this return? Let's see, yes. So this won't return the thing, so that's okay. I mean, we could potentially work around that, but I'm gonna say that for the sake of maybe simplicity or more to have a more general solution, we can use the index. We can call pop, which will actually return us that movie, kind of remove and return at the same time. So, but in order to call pop, we need an index. So we have the actual thing itself. We also want the index. So to get that, we can use
Enumerate.
enumerate. So now we're going to get a tuple. Enumerate is going to return a tuple. So an index.
Will this give you an error because you're modifying a list that you're iterating over at the same time?
Yeah. So we'll just need to exit basically. So you wouldn't want to modify it and then keep going. This should be. There's a so there are a few different ways we could handle it. We could also do more of like a filter thing, but I think this is the most transparent, I think. But yeah, there are a number of ways we could go about this particular thing. Okay, so if we have an index in a movie, Bob, we're going to check, and then we're going to do found movie equals self dot storage dot pop, and then we'll pass in the index, and then a return found movie. So we're going to go through it, we're going to loop through it, we're going to keep checking. If we find it, we'll remove it and then return. Basically, we'll cut out of the loop early. Otherwise, we're going to go all the way through the loop. And that means if we go all the way through the loop and there was no match, that means there is nothing found, so we'll just return none. So I think that
Would that return none on the first loop if it's not the movie?
Yes, sorry, thank you. I gotta move this out here. Actually, I don't need the else. Thank you. So we're gonna loop through it. We're gonna check all of them. If we make it all the way through the loop without hitting that condition, which means there's no match, then we'll return none. Okay, so let's test this out, the remove movie. So if I go to runner, we'll add a movie. And then, yeah, we'll see if that works actually. U dot watch save movie. I think this should print out something. Let's give it a go. Okay. So watch save movie is missing one required positional argument, movie ID. So this is a little tricky because we need to get this idea and ID, and since it's randomly generated, it's going to be an issue. So we're kind of alighting over how you would actually implement this in a real system. You wouldn't require the user to give you an ID. directly. So I'm gonna let's see. I'll convert this to an integer. So I can see what the ID is and then grab it, and then I'll pass in the ID. So this is just kind of to make this work here. All right. So I have this, I grabbed this random movie, and now I can get the ID, which is 8462. Pass that in. So this works. If I pass in, I'll run it again and pass in an ID that doesn't exist. 1, 2, 3, 4. Says you haven't saved that movie yet. So if we have the movie, it's going to return the actual movie object. If we don't, then it's going to return none, and then we're just going to do a check and say, and so on and so on. So it might be good just to make sure. We'll check the we'll call show movies again to see if it was actually removed. So I'll pass in the wrong one, so it shouldn't get removed. So that one is still there, and I'll call it again and actually remove the correct ID. So it says you're watching it, but it since it's empty, it just prints out nothing. So I could make that more explicit in the movie, like if it's empty, where is that? Show movies, like if it's empty, print out, empty or something like that. Let's just do if not. Just to make this a little easier to see, so we'll paste this in, and we can see that there's no movies. So I got a movie, I watched it, which means it gets removed from the list, and then I can see that the list is empty. Okay, so I think that our basic system is working now. So I can create a user, I can save a movie, I can see all the movies, I can watch it, and so on. Okay, so I think this is good for the basic requirements. So we'll move on to tests now. Does anyone have any questions about this as it is?
I had a question about the init, the dunder init files you added.
Sure.
Why why are they important again?
It basically tells Python that this is a module. So when Python is looking for files, it will kind of package them together. Honestly, I don't know exactly the nitty gritty. There's a environment variable called Python path, which gets used. So when you try to import something, it looks in a few different places. It starts, I don't know the exact sequence, but this is other languages handle this differently. So in Java, for example, or Scala, you actually you identify the package that it is a part of in the file itself. So I think that system in some ways is a little clearer, but in Python, you have to use this. And there are also things you can do in the init. We're not going to do anything, but you can also like import things or do setup, or you can expose certain things. So if you have a bunch of things in this module that you kind of just want to be internal, you don't necessarily want to expose to the user, you can actually specify that here. Let me see if there's an example. Let me see. Maybe if I do the regulars. So we're looking at the Python source code. Actually, let me, since we have the virtual environment, we should be able to go to the library. So if I go to requests, so you can see that there's this init. So this is the actual source code for requests, this third-party library we're using. So there's an init, and in our case, it's empty. Often it's empty. Here, there's some stuff going on. There's a few different reasons, but you can see that there's a lot of kind of setup happening here, like checking compatibility. Do you have the right versions of things, and so on. So it's trying to import some things, but it's just doing initial setup. And then let's see, you can see that it's importing a bunch of stuff internally. So it's actually exposing. So there's a whole bunch of stuff going on here that you as the user of requests shouldn't really have to worry about, like, helper methods for other methods and so on. So it's actually importing a bunch of stuff. Here's where we're getting request, actually a get. So from .api right here, import get. So we go here, we can see get. So this is, this is a more complicated kind of real usage of init, but at a basic level, it will just say that this requests library is kind of one unit. Okay.
I had a quick question
Yes,
on
yeah.
this. We got introduced to the raising exceptions. I'm confused on when we should use that and when we would do the else print statements. Like, would I
Yeah.
want to do an exception instead, or?
Yeah, so we could just do that. So this is a very soft, this is a very soft check. Depending on what you're doing, you might want to throw an exception. So let's just throw an exception instead. So save movies, remove movie. So let's say we want to raise exception. So this is this is the most generic exception you can throw. You might want to find a specific one, like maybe value error or something. You could look up, Python has a whole bunch of built-in exceptions, and you can also, create your own subclasses, which are, are customized. So we'll just return value error for the sake of it. I'm not sure that value error would be, yeah, whatever, we'll go with that. So now if we don't find it, we're gonna put on error. So if I run this, so I'll include a bad ID, and we get an exception instead. So our source code here is throwing an exception. So now when we use it, since this could throw an exception, we should probably handle that. So instead of doing this, I'll wrap this in a try block, because now I know this might throw an exception. So if it succeeds, basically, I can do the same thing. It'll end up being the same, but and then accept. And I could do whatever I want to do here. I could maybe do like a retry, you can do whatever you want. In this case, I'll still just print. So let's run this. So if I enter the wrong ID, I get basically the same thing, but I'm handling it a little bit differently. So the source code is throwing an exception. So now when I use it, I basically need to be prepared to handle an exception. So if you're using, if you're using code that can throw an exception, you should probably handle that case.
So
So-
loading exceptions are good because as developers, it shows you exactly where the error is and what happened, right?
Yeah, it depends on what you, it's basically, so you can think of exceptions as two broad categories. One would be like a critical failure, like, an out of memory error or something like that. So if that happens, then you're SOL. But in your application code, an exception basically means like something happened. We expected that. This is why you want to let me do. And actually, when you're catching exceptions, it's better to be specific. This is one reason why it's important to choose or create a relevant exception, because what you're saying here is like, this is either going to give you back this movie, or it's going to throw this error. So like when I create this code, I'm expecting this. So this is like, a bad outcome, but I'm expecting it. So in like Rumsfeld terms, it's an unknown unknown, right? So we have a value error here. So we're expecting either one of two return values, either a movie or a value error. And then when I use the code, I can say, okay, the good outcome is I get a movie. The bad but known bad outcome is I get a value error. So I get this and I handle it. Now, if I get something else, some other kind of error, then like something has really gone wrong. So that's the kind of like, yeah, an error is bad, but if I'm expecting it and I know what to do with it, then I handle it and things move on. What the real bad, like if I got something else, then there's a real problem. So you'd want to handle this, and if something really bad happened, maybe you would just want to throw an exception and crash. Does that answer your question?
Yeah, I guess I'm still shaky on, should we just always be doing exceptions instead of just print statements to signify a error?
It really depends on what you're trying to do.
It also stops the program, right? So like it's not
an
going.
unhandled exception will stop the program.
Yeah. Okay.
So it depends. If you just, it kind of depends on, is this like really critical? Like, should the application stop working if you don't find a movie here? Well, you could kind of decide that as the consumer. So if I really have to have a movie object, then yeah, maybe you should just crash the program basically, because it shouldn't work anymore at that point. Or you say, well, if that does happen, I can handle it this way and then keep things moving.
Chad, for that arrays, like the value error, is that something that you define or that's like
It's
by
it's a built-in. It's a built-in.
Oh, okay, so you just choose which kind of race error that you'll use.
Yes. So there's a whole bunch of these built-in, and they all extend from exception. You can see all of these are classes that extend from exception. there's a whole bunch of, stop iteration. So stop iteration, that's actually how for loops work. It will call next, the built-in next until there's nothing, and it actually throws an exception. That's how Python knows to stop iterating over something, because it throws an exception and then handles it. Like your system doesn't crash when you reach the end of a for loop, but it's just how, internally Python knows to stop. Here's exception. Here it's from base exception. And so you don't need to worry about any of this stuff, but yeah, there's a whole bunch of built-in exceptions. So it's probably best to like look at the list, depending on what you're doing, and see if one of them fits your need. Probably does. If not, then you can write a custom exception. Okay. All right, let's write some unit tests. So I'm going to go into tests, and I'm going to do test underscore, we'll test movie. So I'm going to use the built-in unit test. So import unit test and class test movie, and this is going to inherit from the unit test test case. And I know that all the test methods have to start with test underscore, and we'll just do, this is a pretty simple class, so we'll just test that. And let's look at the movie. Split. Yeah. So we'll just create, let's see. And I'll create an instance of movie. And I'll have to import that. Okay, and then I'm going to create an instance, and I'm going to test, so self dot, this is kind of a obvious test, but cert dot equal movie ID and m dot ID. And I can run this. So there's a couple ways I can run this test. One, I could run this file directly. So I can do the if blah, 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 and then call unit test.main here. I can also, since I'm going to write several test files, it would be nice to run them all at once instead of having to run each file individually. So you can do that if you run unit test as a module. So just like we ran Ven, the virtual environment module on the command line, you can do the same thing here. So Python -m unit test, and unit test will basically, if I just run it, it's going to discover everything and run it automatically as long as I've followed the conventions. So let's see if that works. So it does work. So I ran unit test as a module. It does its magic, finds all the tests, and then runs them. And this one ran and passed. So no surprise there. It's pretty simple. So I think that's good enough for now. You could add more tests, blah, blah, blah. And let's move on to the next component. So let's do saved movies, maybe. So saved movies, I'm going to write test saved. I'm going to do the same thing. So imports unit test class test saved movies. That's going to inherit from unit tests test case. Okay, so what should we test? Where is save movies? All right, so we've got we have our knit. Let's see, add movie, remove movie. Okay. So test, I'll just test add. I'm not going to test everything just for the sake of time, but we'll test adding a movie. Test add movie. So I'm going to have to import that first. So from src dot save movies. So even though like in the system as a whole, I'm not like directly creating an instance, when I'm testing it, I can isolate this. So I can just do whatever I want individually with it, apart from the rest of the system. This is one reason to make things modular and isolated. Makes it easier to test. Okay, so we're gonna do sm dot add movie, and in this case, it doesn't really matter what I'm passing in. I could pass in an actual movie. So in other languages with a stricter type system, with a static type system, we could say that self.storage can only contain, it's a list of movies. It's a list of our movie objects. Python doesn't do that. So we can, this could be a heterogeneous list of anything. So we could just, for testing, we could just pass in a string and see if it works, but let's create an actual movie object. So from source dot movie. All right, and then we'll add the actual movie, and then I will test. So the actual would be, so let's just pick something arbitrary. We'll just say that the length of the movie is 1 now. So self dot assert equal len of the movie objects dot storage. Say that is 1 now. So I can run this python-m unit test, and it will discover, even though these are in two separate files, it's going to discover all of them and run them all at once. So I don't have to individually run them. Okay, so this is working. You can add more tests, but for the sake of time, we're just going to move on. So now if we want to test, let's test user. Usual setup. Okay. So let's take a look at the user. So the user class, maybe we should look at this in full now. The user class is a little bit more complicated, right? So what are some issues with testing our user class?
Pulling in like a lot of different objects.
Yep. So for one, it's, there are some dependencies on other things. So we're going to need an instance of save movies. We need an instance of movies API. What else?
Like fetching the movie and it's a random one.
Yeah, so there's a couple things. And one is that, yeah, the movie that we fetch is random, so that's going to make it hard to test. So it's not, it's not pure, it's not referentially transparent, because every time we call it, we're going to get potentially a different value. The other thing is we're making a network request. So what happens if, the API that I'm using, what happens if the API that I'm using is goes down, or it's having heavy traffic or something like that? Then my unit test is going to fail. And, in some sense, obviously, in order for the whole system to work properly, this has to work properly. But in another sense, this is an external dependency. I don't really have control over these other servers and, the network and everything else that's happening. So when you're doing unit tests, you want to remove those kind of dependencies. One, it's all side effect, right? It's a side effect because it's making a network call, so it's changing something outside of itself. And two, the return value is potentially different every time you call it. So those two things make it an impure function, and impure functions are very difficult to test. And often for stuff like this, like accessing a database, even reading in files, making API calls, you're going to want to remove that as a dependency from your unit test. So the question is, how do you do that? So we want to, well, let's write first just like a random test here. So test, yeah. Test save movie self. I'm going to import this. So from source dot user. Okay, so I create an instance of user, and I want to call u dot save movie, and then I want to check that this has actually added a movie. Well, this is going to call this movies API fetch movie, so blah blah blah. We don't want to have to deal with that because maybe our network is down or whatever, and we don't want unit tests to fail in that case. So the way you handle that is through, we're basically going to have to substitute. We're going to have to substitute something for that. And in this case, the way it's designed, it's fairly straightforward to do that. But so you might have to redesign how you actually implement the code in order to make it testable. So this is one reason why it's good to write unit tests, because it forces you to think about, am I writing this code in a way that it's transparent and that it's modular. So is it just one big function where everything's happening, and then your only insight into it is what you put in and what you get out, and that's really all you can test? Or is it broken up into modules, and I can test each component individually and be sure that the whole system works? Okay, so what we're gonna have to do, I'm gonna show a couple different ways that we can do this. So the first way I'll show is basically kind of a roll your own thing. So you can see from the ground up how we do that. So the one component that's especially troublesome for us is this movies API. Making an external network call, we don't want that in our unit tests. So we're basically going to create a fake movies API. So I'm going to create a class here. I'll just write it inside the test here. So class fake movies API. And if we look at the actual movies API, we'll see that it has this one method and it's going to return a movie object. So if it's, so we're going to create a fake movies API, but it has to have the same shape, right? Because it's going to get used in the rest of this code. So it's got to have the same shape. So it has to have a fetch movie method. And that fetch movie method is expected to return a movie instance. So our fake is going to have to do those two things. So our fake is going to have a fetch movie method. And it's going to have to return, in this case, we can just hard code it, right? So we get control over what's happening. So return movie, I'm gonna have to import movie. And we can do blah, blah, blah. And now what I can do is I can create an instance of the user and I can see what happens. It's going to do all this. It's going to create an instance of this and blah, blah, blah. Now, because of the way this is set up, this is not actually, well, when I create an instance, it's not actually making a network call. So it's, even though it's for a brief moment, there's going to be an instance of the actual movies API, since it's not doing anything, you can just ignore it. And what we're going to do is we're going to say u dot movies API equals fake movies API. So we're creating a regular instance of a user, and after it's created, we're saying, you know what, never mind. We're going to not use the real API. I'm going to give you this fake movies API instead, which doesn't make a network call or anything. So once we have that, we can treat this as a normal object. We can call save movie, and when it calls fetch movie, it's going to call it on our fake API, which is going to return this movie that we're expecting. So then save movie is going to add the movie to blah, blah, blah. So we can check that we can do self.assert. So u dot save movies dot storage. I'll just do the same length check. So when you could do something else more complicated, but for the sake of time, so that's going to be 1. All right, so let's run this test and see if it works. So we ran 3 tests and they all passed. So this test now passes, and I'm not dependent on the network being up or whatever. So I've removed that. I've removed that external dependency from the code. So that's one way to do mocking, basically. So I'm substituting the real thing for some fake thing that's simpler. Okay. So that's one way to do it. Another way would be instead of creating this whole fake thing, we could do let's see. Let me take a look real quick. We implemented that differently. Yeah, okay, so let me think. If we go to the movies API, so we could actually fake this method in particular. So Yeah, so we'll do another version of this. And we'll call this 2. But we're not going to use this fake. We're actually going to use the real one, but we're going to substitute since the problem method. Where are we here? Okay. The problem method is just this fetch movie. It's not like the class as a whole. It's just this right here. We can do something similar, but we'll do u.movies API dot fetch movie. So we're gonna basically override just this method here, and whatever we override it with is gonna have the same shape. So it's gonna basically take no parameters and it's gonna return a movie instance. So we can do that inline with the lambda. It's gonna take no parameters and it will return. We'll just have it return the same thing here. And that should also work. So we're patching or overriding or doing monkey patching. So we're taking the real thing and we're saying at runtime we're saying, your fetch movie method, I'm gonna kind of capture that and give you what I want instead, so that you don't have to make that network call and you can return a predictable value. So if I run this again, so I get 4 tests, and this also works the same. So I'll do one more, which is a little more complicated, and it uses like the actual mock. So I'm gonna do from unit test mock. I'm gonna import 2 things, patch, and there's a whole bunch of these like mocks. They all basically do the same thing. But yeah, I'll use this one. So a mock object is basically just it's a class that will dynamically create whatever you ask for. So for example, if I'll go into the REPL here. If I create trying to think. So I just create a list. So list has a whole bunch of built-in stuff here, right? Clear, copy, count, whatever. So if I try to call x dot something that doesn't exist, I get an attribute error. So it's going to look for it. It's going to look for this thing called something, and it's not going to find it. So it's going to throw an error. If, on the other hand, I'll import this. So if I do m equals, and if I do m dot something, it doesn't throw an error. In fact, it just creates it just creates it on the fly. So whatever I ask for, it's going to just create automatically. So it's like, it's magic in the sense that it kind of becomes whatever you ask it to become. Now, there's no real content here. This something doesn't really do anything, but you can also force it to return. You can add something to a magic mock and then force it to return a specific value. So I can do like m dot something dot return value equals 1, 2, 3. And if I call now m dot something, let me do I think this should work. I might have to call it. Let me try. There you go. So I created, something, and I said the return value is going to be this. So if anything ever calls, something, just return 1, 2, 3. So it's basically like a dynamically created dummy object. So it's a bit weird. So if you're confused by that, that's to be expected. And really, like in an ideal world, you really shouldn't have to use mocks because your code should be pure. But if you're doing a bunch of side effects, sometimes you have to manage that, and mocking is basically how you do that. Okay, so let's see how we could do that. So we've seen 2 ways where we've kind of like hand rolled mocks or patching. So same thing. We're taking something which is too complicated and we're making it simple. So let's do def test. I'm just going to copy all this. Okay, so we're going to create an instance. And the first thing I'm going to do is the real problem here is, so I know we're running late, so I'm going to try to wrap this up real quick here. So the real problem, if we look at the API, is this requests library. So what I'm going to do is I'm going to override the requests library. Test user. And you do that with patch. So this is a decorator called patch. And it's going to add another parameter that you can pass in, which is basically going to be the fake whatever you say this is going to be. So in this case, it's going to be source dot movies API dot requests. So it's going to say, the requests that you're using in movies API at source.movies API, I'm gonna hijack that. So mock, and you pass that in here. This is just how it works. So you pass that in here as a parameter. So now you have control over this requests thing that you're importing. So I can create a user. So the other thing that you're going to want to do is create a mock response. So I can now, I'm hijacking this requests library. Let me see where that is. I'm hijacking the requests library, but I also need to make sure that I'm like returning, I have to like hijack the return values now. So I'm calling get. So I need to make sure that get returns something and also JSON. So I'm calling request.get.json basically. So I'm a couple layers deep into this requests class. I need to mock out request.get.json, and then I can take it from there. So this is, a little weird. Let's see, test user. Okay. So what I'm going to do is I'm going to create, just like I did, I'm going to create like a mock object. So m equals magic mock. And I'm going to do, let me just check this for speed. Yeah, okay. So we'll do m dot JSON. So we're going to hijack the return value. And the return value is what we're expecting, something with name, equipment, and ID. So I'm going to put this all in one object. I'm making 2 different calls here, but anyway, just gonna have to get through this. So name is going to be, oops, and then equipment and then the ID is going to be a number. Okay, so what I'm saying is when I call JSON here, I'm expecting basically a dictionary with these key value pairs so I can access them. And then what I do is whatever get returns is going to be this JSON object that returns this other stuff. So it's a little complicated, but yeah. So m dot get return value equals I should probably call this response.
Is return value something built
Yeah.
into all these?
Yes.
Okay.
Yeah, so right here, looking at this example,
Yeah.
so something is what I made up, but return value is a built-in thing.
Oh, okay.
Yeah, it's the API is a little confusing and the documentation is not great, but yeah. So one thing is you can avoid this by making your functions as pure as possible. Okay, so we've got this. So now we've kind of like just picked out what we need and we've hijacked everything. So we should just get what we expect now. So I'm gonna pass in do user save movie. So I think this should work as is now. Unit test. Okay, so that works. So it's a bit odd, but this is kind of the official way of doing that. So depending on how complicated your use case is, you might be able to get away with kind of inlining something like this, or you might create a little fake thing with just what you need, or you can kind of be more surgical, but it's more complicated, where you're hijacking the actual requests thing, this library that you're importing, and then you're faking everything. So that's mocking. So yeah, so we wrote this Netflix thing, and then when we're testing it, some of it was pretty easy to test. Like the movie, very easy to test. Let me close this other stuff. The movie is easy to test. The saved movies is also pretty easy to test. I can take this as an individual unit and do whatever I want with it. It's controlled. It's not doing anything wacky. The movies API is not, so I could test this. But in order to test this as it is, I would have to fake the whole thing. So it'd be kind of pointless. I could split some of this stuff out, and if this were a more complicated class, it would have other things in it. And then the user, because the user is dependent on this other stuff, which has lots of side effects, we need to control that for our unit test. So that's one reason to minimize side effects, one, and two, to localize them, to put your side effects in one place so you don't have to. I mean, imagine if every single component was doing something like that. You'd have to mock for everything you tested, you'd have to be mocking stuff. Okay, so I know that was long and maybe confusing, especially with the mocking stuff, but are there any questions? All right, well, let's take a let's take a 10-minute break, and then I'll get groups and I can introduce the assignment. It's a continuation of what you've done before, so shouldn't be anything surprising, but yeah, take a 10-minute break, and then I'll just assign I'll assign groups. And if people have more questions about this, I can answer those. If several people want more, I could create a breakout session, but yeah, just let me know.